Hi, I'm Anwesha Banerjee. I am a PhD student in Image Analysis and Computer Vision Lab in ISC Bangalore. I'm here to present my work, AMEND, Adaptive Margin and Expanded Neighborhood for Efficient Generalized Category Discovery. So we are living in a world and era of data. While it's easy to access data, it's quite difficult to get properly annotated data, and it's very time consuming as well as expensive. So in real life scenarios, we might have access to labeled data and a huge amount of unlabeled data, some of which may be from previously seen classes, but most of which may be from previously unseen but similar classes. So here is our problem statement. We have a dataset D which have a part that is labeled set DL and another part that is unlabeled set DU. The assumptions being that images in the unlabeled set belong to the classes YU, which is a superset of YL, which are the classes present in the label set. Now, during the training, the model does not have access to the labels in the set DU because it is tasked at predicting them at test time. Also, it is also an assumption that the total number of classes present in the data set D is known a priori. The objective being we want to cluster the images in the unlabeled set correctly. We are using VITB16 as our backbone. So in our proposed methodology, we use neighborhood information, especially expanded neighborhood information, to make sure that we cluster classes from the same samples from the same classes better and with more precision, and adaptive margin regularizer to ensure that we reduce the confusion between adjacent or similar classes, hence increasing the discriminability. So we have neighborhood information here. So in case of normal contrastive learning loss, we use the anchor image and its augmentation as positive pairs. But here we are using the nearest neighbors as our positive pair. So we have a feature bank and the anchor image. So we find the top 2 or top 3 or even top k neighbors, nearest neighbors, and we use the contrastive, the augmentation and the nearest neighbors as our positive pair in the contrastive learning loss. The formulation is given as follows. In case of expanded neighbors, why are we using it? The reason that we are using it is it might happen that if we keep on increasing the number of neighbors to better aggregate the information, we might end up having a cat having its neighbor as cheetah or a panther. Though they belong to the same feline family, they are not cats, certainly. So to better aggregate the information, we are using neighbors of neighbors, and we are calling it expanded neighbors. And here we are using the anchor image along with its augmentation, neighbors and expanded neighbors as positive pairs in the contrastive learning loss. So total neighborhood loss becomes the summation of the neighborhood loss as well as the expanded neighborhood loss. We are using our standard supervised contrastive loss for the labeled samples. So our final representation loss becomes a summation between our neighborhood loss and our supervised learning contrastive loss. So adaptive margin regularizer is used in our parametric classifier. So the parametric classifier has C prototypes, which is also the total number of classes, and each of the prototypes corresponding to each of the classes present in the dataset. Now the D mean denotes the mean distance between each pair of prototypes, and it is used for stabilizing the regularizer. Now the objective is to increase the angular separation between the prototypes if they are very similar. On the other hand, maintain the at least the d mean amount of distance between each pair of prototypes. We use the formulation given as follows for finding the d mean. Now, as we can see the formulation, we have delta ij. Now this delta ij is the dot product between two prototypes. If they are very similar, the value tends to 1, hence it acts as a margin regularizer. Now we have this proposed methodology overview where we have the training data which we use to find our nearest neighbors and eventually our expanded neighbors, which we run through our backbone and the projection layers and obtain our representations, which we use to find our losses. And then we have our soft loss predictions that we use for our adaptive margin regularizer LM. Now we have used 7 data sets and we have tested our performance across all of these data sets and reported them. We can see the splits between the labeled and unlabeled data given as follows. So some of the implementation details: the batch size is kept as 128, the last block of the VIT B16 is only fine-tuned, the feature bank size is kept at 2048, the number of epochs that is used for training for all data set is 200, and the initial learning rate is 0.1, which is gradually annulled with warm restarts. Now the expanded neighborhood is taken as 5, and the fine-grained for fine-grained data sets the neighbors are taken as 4, while for cipher 10 and cipher 100 it is taken as 5, and for ImageNet it is kept at 6. As we can see from the results slide that our model performs quite well for most of the data sets and at par for cipher 10 and cipher 100. For imbalanced data set, our model performs really well in comparison to the pre-existing methods, and it's quite tough to perform well for heavily imbalanced data set like Herbarium 90. Now for the TSNE on cipher 10 data set, we can compare that how well clustered our models representations are in comparison to raw VIT backbone output. We have considered ablation study and we have reported it. So the best line being the best network that uses the feature bank and the augmentation as positive pair. As we can see, on addition of the neighbors, we have got improved performance, but on addition of adaptive margin regularizer, our performance have improved by quite some amount. Now, as we know that the neighbors and expanded neighbors are our hyperparameters, but it can be seen that while varying these hyperparameters, the performance varies gradually and gracefully across all the data sets. So, here concluding my presentation, we have our references. If you have any questions, please direct it to my email.